Welcome to Education for Next Generation. This is D. Mallikarjun Rao, Physics teacher. Today, let us discuss about electricity. Let us discuss about the basic information for electricity. First of all, we need to know what do you mean by electric charge. Electric charge is a physical state of matter. Just like mass and volume, electricity is also a physical state of matter. Mass of the body can be observed when it is placed or when it is subjected to gravitational force. Similarly, we can identify the electric charge of a body when it is placed in an electric field. So, electric charge means it is the physical nature of a body which can be observed when the body is placed in an electric field. Now, let us see the definition of unit of electric charge. The unit of electric charge is coulomb. Coulomb is the unit of electric charge. And we need to know what do you mean by 1 coulomb of electric charge. As we know that atom contains 3 types of particles: electrons, protons and neutrons. Electrons are basically negatively charged particles, whereas protons are with positive charge. And now let us see the meaning involved in the term 1 coulomb of electric charge in terms of electrons. When 6 into 10 to the power of 18 electrons, when 6 times 10 to the power of 18 electrons are placed at one place, whatever may be the total amount of negative charge present on that number of electrons is taken as 1 coulomb of negative charge. So, 1 coulomb of electric charge means the total amount of negative charge present on 6 into 10 to the power of 18 electrons, that we will call it as 1 coulomb of negative charge. So, 1 coulomb of negative charge means the total amount of negative charge present on 6 into 10 to the power of 18 electrons. Equal amount of positive charge is called 1 coulomb of positive charge. So, 1 coulomb means 6 into 10 to the power of 18 electrons. And we have 2 types of charges. They are positive and negative. There are 2 types of electric charges, positive and negative. So, we have 2 types of electric charges, one is positive and the other is negative. As we discussed already, electrons are with a negative charge, protons are with a positive charge. Let us come to the next part, that is the next important point is electric current. What do you mean by electric current? The rate of flow of electric charges through a conducting wire is called electric current. Suppose here there is a conducting wire AB and electric charges are flowing from A to B. Let us take another point C on this conducting wire AB. Through this particular point C, in 1 second, how much charge is flowing? That is called as electric current. For example, in t seconds time, if q coulombs of charge in t seconds time q coulombs of charge passing through this particular point C. In t seconds time q coulombs of charge is passing through this particular point C. In t seconds q coulombs of charge. In 1 second, how much charge can flow? In 1 second, through this particular point C, how much charge can flow? And the amount of charge is now q by t. So, the amount of charge that can pass through this particular point C and the conducting wire AB is nothing but q by t, and this q by t ratio is called current, denoted by the symbol I. So, finally, the formula to calculate the current I is I is equal to charge q by time t. This is the mathematical expression to calculate the current. So, the definition of electric current is the rate of flow of charge passing through a conducting wire is called electric current, and the formula to calculate electric current is I is equal to q by t. In this, q is in terms of coulombs and t is in terms of seconds. If q is in terms of coulombs and t is in terms of seconds, then the current I will be in terms of amperes. So, the unit of current is ampere. So, formula is I is equal to q by t, and the unit of ampere, unit of current is ampere. Then what do you mean by 1 ampere? 1 ampere of current is equal to 1 coulomb of charge within a time interval of 1 second. So, 1 ampere of current means the flow of 1 coulomb of charge in 1 second, and that is the meaning of 1 ampere current. That means, if through this particular point C, if 1 coulomb of charge flows in a time interval of 1 second, then the flow of current is taken as 1 ampere. Instead of taking 1 coulomb, what is the meaning of 1 coulomb? 1 coulomb is nothing but 6 into 10 to the power of 18 electrons. So, in the place of 1 coulomb, we can take 6 into 10 power 18 electrons in 1 second time, and it is the alternate definition for 1 ampere of current. The alternate definition is, if there is a flow of 6 into 10 to the power of 18 electrons in 1 second, that current also can be taken as 1 ampere current. So, 1 ampere current is equal to 1 coulomb by 1 second, or it is also equal to 6 into 10 to the power of 18 electrons in 1 second. So, this is the information about the charge, meaning, types of charges, and the definition of electric current, and the formula for electric current, and the unit of electric current. This is the basic information we need to know to understand the further topics of electricity. So, next topic for us is about simple electric circuit. What do you mean by simple electric circuit? A source of current, here I have taken as a cell. The long line represents positive electrode, short one represents negative electrode. A source of current, a switch, and a consumer of electric current like electric bulb. When these three are connected up by the means of a conducting wire, that arrangement is called as simple electric circuit. Here, this represents the switch off condition. When the switch is off, there is no current in the circuit, and that circuit is called as open circuit. When switch is on, current starts to flow from positive terminal to the negative terminal, and in this situation the circuit is called closed circuit. In the open circuit, you are not supposed to show the direction of current using arrow marks, whereas in the closed circuit you have to show the direction of current using the arrow marks. Here if you put the arrow marks, that is wrong. Here if you forget to put the arrow marks, that is also wrong. Open circuit, no current. Closed circuit, you can find the current in the circuit. So here in the open circuit there won't be any current, whereas in the closed circuit there is a flow of current. Now next topic for us is about the potential difference V. Let us see what do you mean by the term potential difference across 2 points in an electric circuit. For example, here you see the circuit once again. Here the bulb is connected between the two terminals A and B. Now the current is flowing from A to B through this bulb. Now to move the electrical charges, to drive the electric charges from A to B, the cell need to do some work. And now the definition of potential difference is the amount of work done to drive 1 coulomb of positive charge from A to B along the circuit is called potential difference between the 2 points A and B. Let us come to the explanation part. Here q coulombs of charge is transferred from A to B along the circuit. For that the work done is W joule. Q is the amount of charge transferred from A to B, and W joules is the amount of work done to transfer the electrical charges from A to B. To transfer q coulombs of charge, W is the work done, but to transfer 1 coulomb charge, how much will be the work done? Then W by Q, the ratio, gives you the amount of work done to transfer 1 coulomb of charge from A to B. This W by Q ratio is called potential difference across the two terminals A and B, and the mathematical expression to calculate the potential difference is V is equal to W by Q. And now let us come to the units of potential difference. The potential difference is measured in terms of volt. Volt is the unit of potential difference. Now let us come to the meaning of 1 volt potential difference. 1 volt potential difference is equal to 1 joule by 1 coulomb. That means to transfer 1 coulomb of charge from A to B, if the work done is 1 joule, then the potential difference between A and B is taken as 1 volt. So 1 volt is equal to 1 joule divided by 1 coulomb, and this is the mathematical expression for 1 volt. So there are two observations here. One is potential difference V is equal to W by Q, and the unit of potential difference is volt, and 1 volt is equal to 1 joule by 1 coulomb. So this is the most basic information related to the